Welcome back to Logical Thinking, and today I'm going to talk about the three main types of reasoning we use in logic. These three types are deductive reasoning, inductive reasoning, and abductive reasoning. I'll give you examples of each and try to explain when you'd want to use each and why. The first type of reasoning we're going to be talking about is considered the gold standard reasoning, and this is called deductive reasoning. And this is the type of reasoning that produces valid inferences, meaning the conclusion logically follows from the premises. Syllogisms like modus ponens, which you see here, is an example of deductive reasoning. And pretty much all of mathematics uses deductive reasoning as well. Proofs are a great example of using deduction to arrive at certain conclusions. And deductive reasoning typically starts with general ideas where you reason your way to a specific conclusion. So sometimes you'll hear it considered to be top-down reasoning because you start with rules or axioms which are assumed to be true or maybe are self-evidently true, and then you arrive at specific conclusions. And as a result, deductive reasoning is usually considered to be the strongest form of reasoning because you end up with results that are logically airtight. Throughout most of these videos, I'll be introducing you to the main deductive forms, including methods of proof, to help your thinking be more precise and airtight. And Aristotle's syllogisms, which were written almost 2,500 years ago, are the first examples of deductive reasoning we have in history. Now, logical deductive arguments are going to organize propositions in a way where the conclusion logically follows. So what we do is we take a collection or a set of propositions and we separate them. Some of them are going to be called premises, and we're going to start with those and assume those are true, and we're going to choose one of our propositions to be the conclusion, and this is kind of like our goal. And if we can demonstrate that when the premises are true, the conclusion has to be true, we have a valid argument form. And in that case, the conclusion will logically follow and must be true. One of the reasons we study logic is it'll help us separate the form of arguments from their content. And as a result, we can quickly look at an argument structure and decide if it's a valid argument simply just by looking at the form of the argument. And what you'll see is most arguments fall into one of just a few simple forms, and we'll talk about all of them. And if an argument doesn't have one of these forms, then you can't say the conclusion follows deductively. One way I like to think of deductive arguments is like a set of dominoes. A valid argument is like arranging your dominoes in such a way where if the premises are true, then the conclusion is necessarily true, meaning if the premise dominoes fall, then the conclusion domino will fall by the arrangement. And what we call a sound argument is an argument where not only the conclusion domino is placed in the path of the premise dominoes, meaning you have a valid argument, but also one where you know the premises are true or the premise dominoes fall, meaning you can be sure the conclusion domino is true, meaning that sound arguments are guaranteed to have true conclusions by logic itself. Here's an example of a valid argument. This is a classic one. Premise 1 says all men are mortal. Premise 2 says Socrates is a man, and from there we can conclude that Socrates is mortal. From here you can see this sort of top-down reasoning in action. We're going from the general to a specific example. Now here's an example of an invalid argument. Premise 1, all men are mortal. Premise 2, Sprocket is the name of my dog, and the conclusion being that Sprocket is therefore mortal. Now this doesn't follow because these premises aren't linked in any logical way. There's no logical relationship. This is like trying to conclude that a certain domino will fall, but it's not really in the path of the falling dominoes. This is what we're going to be talking about when we talk about valid argument forms, ensuring that your arguments are structured in a way where the conclusion logically follows from the premises. Now once again, invalid arguments can still have true conclusions, but they're bad arguments because they don't link the truth of the conclusion to the truth of the premises. Another thing to consider is that arguments can be valid but unsound. When we talk about validity, we're only talking about the structure of the argument, not necessarily whether or not the premises are true. So one example of a valid argument that's unsound is something like this. Premise 1, all birds can fly. Premise 2, penguins are birds. And our conclusion is therefore penguins can fly. This is an interesting argument, but of course it's wrong. Premise 1 is false. There are flightless birds such as penguins. So this is an example of where your reasoning can go wrong. You can still have a valid argument, but if the premises are false, then even if the conclusion would follow, because the premises are false, we can't conclude the conclusion is true. So how do we know if and when an argument is valid? Well, over the last several thousand years, there have been a few forms of argumentation that work and quite a few that don't. So if your argument follows one of the structures that we'll talk about, you can be sure your argument is valid. And therefore, if your premises are true, the conclusion must be true. And the examples we're going to be talking about are modus tollens, modus ponens, the hypothetical syllogism, the disjunctive syllogism, and the constructive dilemma. Don't be scared off by these fancy words. We'll show what these look like symbolically and give examples so you can understand them. The next type of reasoning we're going to talk about is one called inductive reasoning, and this takes a more bottom-up approach. This is when we use specific examples to reason our way to a more general example. And a really good example of induction is like saying, look, the sun has risen every day in the past, therefore it will rise tomorrow. However, due to the fact that we often only observe a finite number of things, there can be exceptions that disprove an inductive rule. And as a result, inductive results are generally held more weakly than deductive results. One famous example of induction going wrong has to do with the existence of black swans. Europeans used to think all swans were white because every swan they had seen for centuries had been white. However, in 1697, a Dutch explorer found black swans in Western Australia, disproving years of common knowledge. And issues involving induction were put famously by Scottish Enlightenment philosopher David Hume, who argued induction itself relies upon the assumption that the past predicts the future. We all make inductive inferences, but it seems like we can't non-circularly justify them. Still, induction forms an important part of scientific inquiry, as we often assume certain laws and things hold, at least until we have evidence to the contrary. As Hume mentioned, a wise man apportions his belief to the evidence, but these issues around induction remind us to remain open-minded and always search for new evidence. One specific type of inductive reasoning is called analogical thinking, which uses analogies or similarities between things to draw new conclusions. Some philosophers think all reasoning is analogical in nature. One often needs to be careful using analogies because they can be oversimplified and can lead us to incorrect conclusions without realizing it. As statistician George Box famously said, all models are wrong, but some are useful. However, using analogies can help people find solutions to problems they may otherwise struggle with. Consider the famous Watson card tasks, which basically is going to put these cards out and say which card or cards must be turned over to test the idea that if a card shows an even number on one face, then the opposite face is blue. Think about it for a second. You may want to pause the video, but actually many people get this wrong. The correct answer is to switch over the 8 card and the red card. Many people understand we need to check the positive case, but fail to take into account that if the red card has an even number, then the rule is broken. However, if we change the scenario, if we use the same kind of idea, but in a different scenario using an analogy, a lot of people will actually get the answer right. They'll actually remember to check this negative case and the positive case. So for instance, imagine this. You're a police officer checking the rule, if you are drinking, you are over 21. And people generally correctly identify the drinking beer card, check for their ID, and the 17 card. Once again, the analogies can help us get to the correct solution, but we also need to be aware of when they fail. In later videos, we'll talk about some of the mechanics behind the Watson selection task, but for now, remember that analogical reasoning is a type of inductive reasoning, and while inductive reasoning can be wrong and is weaker than deductive reasoning, it is still useful for us to use. The last type of reasoning is called abductive reasoning, sometimes called the method of competing hypotheses, introduced by C.S. Peirce in the latter part of the 19th century. Abduction evaluates competing hypotheses based on their explanatory power, among other things like simplicity and lack of introducing new contrived assumptions. Like inductive reasoning, abductive reasoning does not provide logically airtight conclusions. After all, the true hypothesis may not be one of the options considered. However, this kind of reasoning is used all the time when we have an incomplete picture and need to make a decision. Abductive reasoning is often used by detectives who may have several competing theories. For example, if a detective finds a body, they'll need to consider suicide, murder, and an accidental death throughout the course of their investigation, and maybe they'll find that certain clues better fit one hypothesis over another, such as evidence of a forced entry or the testimony of witnesses that are better explained by a certain hypothesis over another. Using abduction amounts to spelling out the different hypotheses and seeing which one best predicts the data, often using likelihood or probability as a metric for deciding between them. For instance, it may be possible that someone slipped and fell on a knife that happened to have someone else's fingerprints on it, but this hypothesis may involve additional questions or assumptions, such as where the fingerprints came from, that a murder hypothesis would not. Puzzle games like Mastermind or Wordle tend to be played with abduction, where the player tries to guess what a hidden code is, given some information but kind of an incomplete picture. Though I should also mention, there are deductive ways to solve these problems too, via information theory. Most of this course will focus on deductive reasoning. However, it's important to understand the different types of reasoning out there. Sometimes we don't have enough information to make a deductive conclusion, and in these cases we may use inductive or abductive reasoning for evidential support, or meaning evidence, in premises for an overall deductive argument. Often in science, for instance, people use deduction, abduction, and induction to create hypotheses, construct experiments, and have tests for falsification. In a lot of cases, it's good to use different kinds of reasoning based on the evidence you have available, though once again, some fields may use one type of reasoning over another, such as we saw with mathematics. Furthermore, these types of reasonings can be combined in different ways to get closer to truth. For instance, you can use abduction to decide between different hypotheses, but use deduction to conclude that a given hypothesis contradicts the observed evidence, or induction to estimate the likelihood of an event happening based on their past experience. Think about the decisions you make in everyday life. Are they more deductive, inductive, or abductive? Perhaps they are a bit of each. Thanks for watching, and I'll see you in the next video.